Hi, I'm Jonathan Iliffe. I'm from University College London, and I'm going to tell you something about the use of SnakeGrid on the HS2 system, advantages and disadvantages or whatever. First of all, I guess the the main, why would you use SnakeGrid on HS2 and so on? It's the most obvious answer is it is being used. So the SnakeGrid is the SnakeGrid eastings and northings coordinates are what are used for the HS2 system. So it's not a kind of optional thing of I wonder if it'll be useful for my project or not. It's something which is there, and it underpins all the spatial data for HS2. So the question is, why, who, what, why, where, and why. I could go on about this for hours and hours, and but in the 10 minutes I have available to me to try and cut to the chase, as it were, I'll very briefly tell you what it is, why there are advantages to it, and how you get access to it. The what, I suppose, is very, very simple. You can show it in one slide with a couple of pictures. This is what we're trying to do. SnakeGrid is purely about trying to introduce a coordinate system that matches reality. If you can read that on there, that it essentially says that something which you measure off a map in its crudest form is the same as what is on the ground, in a more sort of precise kind of concept. A radius of curvature, which is designed to be of a certain length in a design system, gets created on the same length on the ground. It doesn't suddenly change when you go between the map and the reality, or the coordinate system and the reality. So fundamentally, that's what HS2 wants to do. If you're not used to coordinate systems and map projections and so on, you might kind of be thinking, well, I thought that's the whole point of a map, was it's supposed to represent reality. Sometimes it does, of course, for a very small sort of project. The problem actually, the problem is the curvature of the Earth, and the HS2 is a large enough kind of project that we have to worry about the effect of Earth curvature upon it in that respect. For a small project, it's relatively easy to establish a local coordinate system, to do a survey around our construction, and to create a one-to-one relationship between what we have on the ground and what we have in the coordinate system. As the project grows, that becomes more difficult. You might then say, well, what about a coordinate system that represents a whole country? For example, the OS National Grid. And of course, there is one that does represent the whole country, but the distortions on it are large and they're variable. So if you go to the Birmingham end of the phase 1 of the project, for example, it's got a distortion of around about 400 parts per million. And if you're not familiar with those sort of figures, that means every 100 meters is distorted by 4 centimeters in the Ordnance Survey system. And you go down to the London end, and it has a very, very different distortion. It's a little bit closer to unity. So it's a variable distortion, and it's a very significant distortion. And so the issue with a coordinate system that tries to cover a large area like that is that it has these large distortions. So the trade-off that you really want to establish is continuity or accuracy. I mean, on the one hand, on the left-hand side of that screen just there, we've got the equivalent of a site grid. We have low distortion, but it's only applicable to a very narrow sort of area. It's just around the particular site that we're dealing with, and we can have these very low one-to-one relationships for site grids for something which is maybe the size of a London borough, but not the size of HS2. And on the right-hand side of the screen there, we've got coordinate systems like the Ordnance Survey National Grid, which have got a wide applicability, but correspondingly high distortion. So we kind of like the top line of both of those. We'd like a coordinate system which has a wide coverage, but has a low level of distortion. So how do you do that? There's one possible approach, I suppose, which is what HS1 did when it was first of all being constructed, and that's to introduce a kind of a zonal concept. Something, this is sort of a schematic diagram of that one just there, but essentially you change the coordinate system every few kilometers as you go along the system. So within each of those individual coordinate systems, the distortion is low. You can have a defined relationship between adjacent coordinate systems, but of course you've got the problem that you know, halfway along a very complex sort of calculation of a transition curve, suddenly your coordinate system changes. So you achieve low distortion at the expense of continuity. So HS2 SnakeGrid is designed to get the best of all of those worlds. So I'm going to leap over the sines and the cosines and the secants and how we actually achieve this. But I'm just going to show you the end result, really, which is a map of the horizontal distortion of the HS2 coordinate system when using the SnakeGrid system. And green is good on that diagram. Green is a distortion of less than 20 parts per million. That's 20 millimeters per kilometer, or 2 millimeters per 100 meters, and so virtually an ignorable amount. And you can see over a wide swath from London to Birmingham, and then eventually on further, there will be this very low distortion. I've jumped over things like the height effect that often that will also affect a coordinate system. And so if you're looking for a more detailed explanation of SnakeGrid, you can see what I've also done on that one is to flatten out the effect of things like the Chilterns and the horizontal distortion that they cause. Well, that's the why, I suppose. The what and the why. The how. How do you use SnakeGrid? Well, it may be that if you're simply using it, that's kind of end of story. My digital mouse is going to show up here. If you're in this part of the working in these coordinate systems, just here, you simply need to, sorry, I'm trying to use my digital mouse, so it's not quite working. If you're just in SnakeGrid, Eastings and Northings coordinates, you just need to know that it is a low distortion system. I suppose more relevant to the how of using coordinates is if you're trying to do transformations and change it from one coordinate system to another. So, for example, GNSS data, GPS data, and so on would come in as the equivalent of geographic 2D data in latitude and longitude on the ETRS-89 system. So you want to know how to relate that to SnakeGrid coordinates, or it could be that you're trying to relate everything to National Grid coordinates on OSGB 36. And just as that arrow would be achieved through an algorithm such as OSTN 15, so also the SnakeGrid transformations are achieved through the SnakeGrid algorithm, which has plugged into it the particular set of parameters relating to phase one. So far, phase one of HS2. And then there will be, we hope, an extension of the SnakeGrid coordinate system going further north. So you move around those different arrows by using these different algorithms. And just as the OSTN 15 algorithm will be input to certain kinds of software, then you will also want to know that the SnakeGrid algorithms are plugged into other different to certain kinds of software, and we have various different things like SnakeGrid Pointwise for the free download for coordinate sets, SnakeGrid Transformer, a plugin for MicroStation, and in the context of FME, there are a couple of plugins, SnakeGrid Projector and SnakeGrid Object, which will enable FME to accept that HS2 parameter file, and also the ones like the Crossrail parameter file, the East-West parameter file. So you can flick between all the different projects within SnakeGrid Projector within FME by having SnakeGrid Projector as a licensed plugin. You can also access HS2 coordinates through the algorithms embedded within various third-party software. So some of these other manufacturers have it or its equivalent embedded within their systems, and then also within the context of HS2, there's also an open source format based on the NTV2 format, which has been implemented for SnakeGrid, and that's another way of implementing it. But you can't use at the moment NTV2 on by any means all the SnakeGrids which are in use throughout the rail system and indeed on some of the road systems. But NTV2 is implemented for HS2. Okay, I think that's around about a 10-minute presentation. I hope that wasn't too fast, but giving you a little bit of a flavour of how to use the system there.